Support handout number 17. Problem 1 is a review on solving trig equations. So the first thing we do is we get that sine x by itself. I would add 3 to both sides, and then I would divide both sides by 3, turning this into sine x equals 1. Then I want to find all the solutions within one period. We're working with radians here, exact radian solutions. 1 makes me think unit circle. Where within one period could I have a sine ratio of 1? I believe this is the only spot. Sine is the b coordinate on the unit circle. So the only angle in radians, the only number that would work, would be pi over 2. That would be the one and only solution within one period. Since I want all the solutions, of course, I can circle round and round as many times as I want and find other solutions, which means I can add any multiple of 2 pi to this. Here is an expression for all the solutions of the equation. Problem number 2 is similar. We'll get that cosine x by itself, so move the root 2 over to the other side and then divide both sides by 2. I have here cosine x equals root 2 over 2. That's one of our familiar ratios. That's how I'm going to be able to do this one by hand and give an exact answer. Let's see, within one period, where could the cosine function be positive? Well, I know it can be positive in the first quadrant. All students take calculus. It's also positive here in the fourth quadrant. And I know that root 2 over 2 is the rationalized version of 1 over root 2. This is just the 45, 45, 90 triangle. I have 1 in the first quadrant. I have 1 in the fourth quadrant. And so this angle here is one of my two solutions. The other one would be this angle here. Remember, at first I'm looking for all the answers within one period. So pi over 4 would be that first quadrant angle. And then in the fourth quadrant, that would be 7 pi over 4, the 45-degree spot in the fourth quadrant. Those are the two answers within one period. Of course, I can add multiples of 2 pi onto these in order to find all the solutions. And we're finished. Problem number 3, I want to find exact simplified values here. I'm not touching the calculator. I'm also not using identities. So take a look at part A. Maybe the first thought that came to your mind is the sum identity for sine, but I don't need to do that because pi over 6 and pi over 3 are just numbers that I can add together. I would need to get a common denominator. It would be 6. If I multiply top and bottom by 2 on that second fraction, that will turn it into 2 pi over 6. Pi over 6 plus 2 pi over 6 is 3 pi over 6, which reduces to pi over 2. This is why I don't need an identity. I'm just being asked to calculate sine of pi over 2. That's 90 degrees up here at the top of the unit circle. And so, of course, the answer is just going to be 1, the b coordinate. Letter B, I just need to find each of these two trig ratios and add them together. A 30, 60, 90 triangle ought to do it. In fact, I can use the same triangle for both. Let's label it correctly. Sine of pi over 6, that's sine of 30 degrees, opposite over hypotenuse, that's 1/2. Sine of pi over 3, that's 60 degrees. When I look at that angle, the opposite is root 3 divided by 2, the hypotenuse. And I can add these together because I have a common denominator. So I'll get 1 plus square root of 3 on the top and then 2 on the bottom. Part C, same two ratios, now I'm just multiplying. So I'm going to take that 1/2 that we found, and I'm going to take that sine pi over 3 that we found, the root 3 over 2. When I multiply them together, I get root 3 over 4. Part D, let's see, 2 here goes into 6 3 times, so this is just sine pi over 3, and we've worked that out already. It was square root of 3 over 2.